All right, this is 2021 Axonometric question part B3 Part B, and we're going to do the trimetric projection of this table tennis table. Okay, so it's going to be located here in your in the center of your axis, and the solution is given to you in the pictorial sketch below. Okay, so just remember that that's what the solution is going to look like. So I'm going to start off with the net itself. So in the elevation, these 2 points here, that line represents the net, whereas this rectangle represents the net in your end elevation. I'm going to bring down the 2 points for the net parallel to the x-axis. Here. So this point here will represent the bottom of the net. And this point or line will represent where the top of the net will be. So now setting up my set squares parallel to the z-axis. This point here, that's the bottom point of the net, so where it hits the bottom line of the net here, that's a point in the net. Top of the net, where it hits the top line of the net, there we go. Bottom of the net, it's the bottom line of the net there. And top of the net, there. Now, with that information, we can harden in the net. So I'll pause this video and I'll bring it back whenever I've hardened in the net. So I'm just joining these 4 points here. Okay, top of the net, drawn and completed. Okay, the top of the table. So I'm going to bring down these 2 points parallel to my x-axis. And these 2 points have already been brought down, but I'm just going to bring them down further so as I can draw the full length of the table. Okay, so I'll start off by taking or extending these points down further. And then parallel to the x-axis, where they intersect that point and that line, and over here where it intersects that line and that one. So they're the 4 points. So again, here and here, there and there. So there's the table net. So again, I'm going to harden them in. So there's the top of your table. So now I'm going to look at the curved points. So I'm going to bring down this point, the top, and these 2 points first. So I'm going to bring them down parallel to my x-axis. Already brought that down. Now parallel to the z-axis, I'm going to bring down all of these points are along this line. Okay, so the ground point would be here. The 25mm height, I've already measured up 25 to get this point. The top point would be here. The opposite, the back 25 point again would be at 25 and the back point here. So by bringing down 1, 2, 3, these 3 lines, I'll have the information I need. So that line's already brought down. So now, where this line meets this line, that's 1 point in my curve. Where this point meets this point, that's another point in my curve. Top point of my curve is there. Back point here, this one and this one. Intersect there, and this point and this point intersect there. So my curve goes up, hits there, and finishes in this direction. Now I have too big of a gap between that point and that point. So I want to create 2 more points here. How I'm going to do that is I'm actually just going to, I could use a protractor for this. From the center point of the circle, I'm just going to go up at 60 degrees. Okay, so if I set up my set square to draw a 60-degree angle from the center point and 60 degrees in the opposite direction, So I'm just creating new points that I can use to let this drawing become a wee bit more accurate. Okay, so take distance across the two of those. So now I have a height for these points. So if I take the height of my compass, apply it over here. So now I've got a height applied on the same line. So where these 2 points come down parallel to my x-axis, where they intersect this point here, that would be 2 new points, which will allow me a more accurate freehand sketch. So I'll take the height down first. And then parallel to the x-axis, I'll take down the 2 points to intersect it. So there's one. And there's the other. So that gives me 2 more points. And now I feel more confident about freehand sketching this in a little bit accurately. Okay, so I'm just going to do this nice and quickly. If this was an exam, I'd take a lot more time to do it with more care. Okay. Now, I also know these 2 points join as supports back up. So what I can do here is parallel to my y-axis. Okay, so take that point straight up to there and take this point straight up to here. And that gives me the points that the supports join to. There. And there. So now, if I wanted to very quickly draw the back curve, it's going to be in exactly the same shape as the curve I have at the front. So this point hits this line there, so that's going to be the back foot of the same kind of semicircular table shape. So I'm just going to take the distance between the front leg and the back leg, and that distance will remain the same the whole way through. So this support on that same line. I'm not going to see the top point. I will see this back point here, so I'll mark it in, and I'll just give myself a point here so as that I have something to, so the curve will start up in this direction, disappear behind the table, of course heading towards that point, and then finish in this direction, but we're only going to see a small portion of it. Likewise, I might just take that across to there, because we will see, I would imagine, a little bit of that support. There. All right. I took that at the wrong angle, apologies. Use 30 degrees, I should have went parallel to the x-axis, or from there. So the table, the support arm would be there, so I'll just rub that one out. Okay, and that is that part of the video complete.